expectation. This is a really important concept in probability. Look at what we have here, right here. The expected value of g of y, given that x equals little x. What does it mean? I don't know. Let's think about an example. Suppose that x is the random outside temperature. It could be 50, it could be 150. I don't know. Maybe y is the number of snow cones that you sell. Okay? Maybe these two variables have something to do with each other, right? Maybe the higher x is, right, you're going to probably sell more snow cones when it's hotter, right? And then finally, maybe g is how much money you make as a function of the number of snow cones you sell. Maybe, you know, maybe it's your total profit based on the number of snow cones you sell. Maybe your total profit is like negative $10 plus a quarter for every snow cone you sell, or something like this. Maybe you've got a certain setup cost of $10. So maybe it's a linear function. Maybe it's not even quite linear. I don't know. I don't know anything about snow cones. But in the end, your profit is a function of this random variable, which is the number of snow cones you sell. And this may be tied to, or somewhat predicted by, sorta, the temperature outside. Okay? So you might be interested in something like this. Expected value of your profit as a function of this random variable y, which is the number of snow cones you sell, given, say, that x is, given that the random temperature takes on this value of 79 degrees Fahrenheit, something like that. Okay? Or more generally, just replace that temperature with a little x. And then, in fact, this conditional expectation is what you call it, because you're conditioning on x being taken on the value of little x. This conditional expectation is a function of little x. Okay? It's a function of little x. Now, how do you define this? Well, it's no secret. In fact, I think I know exactly how to define this, because I know how to define the expected value of a function, of a random variable. It's I'm going to need a density function for that. Well, which one do I need? The conditional density, that x equals x. The conditional density of y, given that x equals x. Yep. In fact, that's exactly what you want to do. We have a couple of cases here. If y is a continuous random variable, or if y is discrete. Okay? If y is a continuous random variable, look, what you have here is you want to say, given that x takes on the value of little x, given that x takes on the value of little x, let's use that density function for y. Okay? And of course we need the dy there. So all of this is basically, you know, given that x is set to be little x here, then all of this is sort of the probability part. It's sort of the chance that y takes on a value between, say, little y and y plus dy. And then you're going to add up all the values of g evaluated at y, weighted against this probability part. Okay? It's just like expectation, except you're conditioning on the value of x. Okay? You're setting x to be some value of little x. Or in the discrete case, it's a weighted average. Right? Here are the probability weights. They're conditional probabilities, but hey, conditional probabilities are probabilities too, right? Saying, given that x is x, chance of y being little y, right? Just going to average all of these guys with respect to these probability weights, right? That's all there is to it, folks. Well, there's actually a lot more to it, but that's all we're going to really do, except for this big example here. Check this out. Find the expected value of y given x equals a half when the joint density of x and y is given by 2 times the indicator function of x and y both being in the unit interval and x plus y being in the unit interval. Okay, I drew a nice little picture here. I think that's a pretty good drawing, don't you? This is a triangle. Note that this is the region that where x and y are both bigger than, or at least 0, and also where x plus y is between 0 and 1. Some of you might have a hard time figuring that out. One thing you could do is you could say, let's look up here at this, and what if I rearrange this part right here just a little bit? I could say that's like y is less than or equal to 1 minus xa, right? Or let's just graph the line y equals 1 minus x. Y-intercept is 1, slope is -1. That's the line, right? But we actually do want y is less or equal to that line, so y is less or equal to that line. Okay, pretty simple. But you need that all this stuff is all your y and x values are greater than 0, or at least 0. Okay, excuse me. So that's the region that you're integrating over. That is this joint density function takes the value of 2 over this region. So it's 2, like it's like up here. It's like 2 in this triangular region that's floating up above the triangle, floating, 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 and then it's 0 down here in the plane. Okay, maybe here's a better picture. Okay, sort of looks like a wedge of cheese or something. Okay, you can see this joint density function is 0, where all outside that triangular region, and it's technically, I guess these ought to be dashed like that, like all your hopes, dashed, right? This then is the triangular part that's floating up there. It's 2 units high. 1 unit that way, 1 unit that way. So what's the volume of this thing? Well, it's area of the base times the height. The area of the base is 1 times 1 times a half. It's a half times the height, 2. 2 times a half is 1. Good. It satisfies the axioms for probability, I guess. So that's good. All right. So what is it that we want to do here? I forget. We want to find the expected value of y given that x equals a half. First of all, let's take a wild guess at it. I'm saying if x equals a half, here's my x-axis. If x equals a half, meaning that it's right here, okay, then what's the expected value of y? Well, it could be rather complicated if that density function was, like a roller coaster or something right there, but it's not. It's flat right through there. It's flat right there. In fact, given x, y is uniformly distributed from here up to here, right? So in fact, the expected value of y ought to be a quarter, I think. See that? It's a half of a half. So let's see if that's what we get. Now, first of all, in order to carry all this out, the first thing I'm going to need, now here, y is a continuous random variable, right? Yeah, so first thing I'm going to need to do is get this conditional density function. So that's how I'm going to start.